Did you know that using premium fuel in most cars can actually make them run worse? Sounds crazy, right? Well, that's just the tip of the iceberg when it comes to the car myths that people still fall for every day. From wasting money on useless upgrades to bad habits that could ruin your car, we're diving into 10 car myths that are not only wrong but downright stupid to believe. Stick around, because knowing the truth might save you a fortune and keep your car running like a dream. Let's bust these myths. Myth number 1. Key fob signal range increases near your head. Verdict: true. The fluids in your head act as a conductor and amplifier for the key fob signal, allowing it to travel farther. This is due to the electromagnetic properties of the signal, which can be enhanced by the conductive materials in your body. While it may look odd, holding the key fob near your head can help you unlock your car from greater distances, especially in crowded parking lots. Alternatively, a water bottle can achieve the same effect since water has similar conductive properties. Number 2. Premium gasoline improves all cars' performance. Verdict: false. The belief that premium gasoline improves performance in all cars is a widespread misconception. Premium fuel has a higher octane rating, which means it is more resistant to premature ignition under high pressure. This characteristic is essential for high-performance engines specifically designed for it, as they operate at higher compression ratios and require fuel that can handle the increased pressure. However, the majority of modern cars are engineered to run efficiently on regular gas. Using premium fuel in a car designed for regular gasoline will not improve performance, fuel efficiency, or engine longevity. In fact, it could potentially cause the car to run less efficiently since the engine isn't calibrated to take advantage of the higher octane levels. Number 3. You can go 10,000 to 12,000 miles without an oil change. Verdict: false. Modern engines are built with tighter tolerances and often use low-tension piston rings to improve fuel efficiency. However, these components are more susceptible to damage if the oil becomes dirty or degraded over time. Contaminants like carbon deposits, moisture, and combustion byproducts accumulate in the oil, and if not changed frequently, this sludge can cause piston rings to stick, leading to poor sealing, increased oil consumption, and even engine failure. For typical stop-and-go driving, where the engine faces more wear and tear, it's advisable to change the oil every 5,000 to 7,500 miles or once a year. For highway driving, where the engine runs more efficiently, intervals can be extended up to 10,000 miles with high-quality synthetic oil. Number 4. All motor oils are the same. Verdict: false. The assumption that all motor oils are the same is a misconception that can lead to poor engine performance and long-term damage. Motor oils vary significantly in their formulation, viscosity, and intended use, and choosing the right oil for your vehicle is critical to its health and efficiency. The primary distinction is between synthetic oils and conventional oils. Synthetic oils are chemically engineered to provide superior performance under extreme conditions, including high temperatures and cold starts. They resist breakdown, flow better at low temperatures, and maintain viscosity at high temperatures, making them ideal for modern engines with tighter tolerances. Conventional oils, while less expensive, lack these properties and break down more quickly, especially under heavy use or in harsh conditions. Furthermore, motor oils come with different viscosity ratings, e.g., 5W30 or 10W40, which indicate how the oil flows at different temperatures. Using the wrong viscosity can lead to poor lubrication, reduced fuel efficiency, and even engine damage. Number 5. Rolling down windows saves gas compared to using AC. Verdict: false. The idea that rolling down your windows saves more gas than using the air conditioning is rooted in older automotive design, but is no longer accurate for most modern vehicles. Decades ago, large, inefficient air conditioning compressors required significant engine power to operate, which noticeably reduced fuel economy. However, advancements in technology have made AC systems far more energy efficient, and their impact on gas mileage is now minimal. On the other hand, Driving with your windows rolled down, especially at highway speeds, increases aerodynamic drag. This drag forces the engine to work harder to maintain speed, negating any fuel savings from not using the AC. Studies and experiments have shown that the difference in gas mileage between using AC and rolling down windows is negligible in most modern vehicles. For instance, at city speed, rolling down windows may have a slight edge since wind resistance is less of a factor. But on the highway, the increased turbulence from open windows often leads to worse fuel efficiency compared to running the AC. Number 6. Idling saves fuel compared to turning the engine off. Verdict: false. The belief that idling your car saves fuel compared to turning the engine off is a misconception that wastes fuel and increases emissions. Modern engines are far more efficient than older models, making this myth outdated. Idling consumes fuel unnecessarily while the engine runs without moving the vehicle. On average, an idling engine can burn 0.5 to 1 gallon of fuel per hour, depending on the size of the engine. In contrast, restarting the engine uses only a small amount of fuel, equivalent to just a few seconds of idling. This makes turning off the engine the more fuel-efficient option if you anticipate being stopped for more than 30 seconds. Furthermore, prolonged idling can lead to other issues, such as carbon buildup in the engine, which can negatively affect performance and longevity. Modern vehicles are equipped with efficient starters and advanced ignition systems designed for frequent starts, meaning that turning the engine off and back on doesn't cause excessive, whereas it might have in older vehicles. Many vehicles now have start-stop technology that automatically shuts off the car's engine when idling and restarts it when the accelerator is pressed. Number 7. Tires don't impact fuel economy. Verdict: false. Poor quality or improperly maintained tires can increase rolling resistance, which means the engine has to work harder to keep the car moving, consuming more fuel. For example, underinflated tires cause more surface area to press against the road, creating additional friction and reducing gas mileage. Even overinflation can have a negative effect by reducing traction and causing uneven tire wear, which might compromise safety. Furthermore, not all tires are created equal. Low-resistance tires designed for fuel efficiency can improve gas mileage, while aggressive tread patterns like those on off-road tires can increase friction and reduce efficiency on paved roads. Proper tire alignment, rotation, and inflation are essential for maintaining optimal performance. To improve fuel economy, it's crucial to invest in high-quality tires that match your vehicle's intended use and maintain them properly. Number 8. Overfilling your gas tank after the pump stops is fine. Verdict: false. This practice can cause more harm than good, both to your car and your wallet. Modern vehicles are equipped with an evaporative emissions control system designed to capture fuel vapors and prevent them from escaping into the atmosphere. This system includes components like an evap canister, which is specifically designed to handle gasoline vapors, not liquid fuel. Overfilling your tank can cause raw fuel to enter the EVAP system, saturating the canister and damaging its ability to function properly. Once the EVAP system is damaged, you may face costly repairs, as components like the canister can cost hundreds of dollars to replace. Furthermore, a malfunctioning EVAP system can trigger a check engine light and potentially fail emissions tests in regions where they're required. Overfilling can also lead to fuel spills, wasting gas, and harming the environment. It creates a safety hazard, as spilled fuel is flammable and toxic, posing risks to you and others around the fueling area. When the gas pump clicks off, it's a signal that your tank is full and you should stop refueling. Number 9. Cars always need frequent tune-ups. Verdict: false. The notion that cars require frequent tune-ups is outdated and doesn't apply to modern vehicles. Today, most cars are equipped with advanced, computer-controlled systems that handle these adjustments automatically. Fuel injection systems have replaced carburetors, and electronic ignition systems have eliminated the need for points. Iridium or platinum spark plugs commonly used in modern engines can last over 100,000 miles before needing replacement. Similarly, Many engines now feature hydraulic or self-adjusting valves, which don't require periodic adjustments. For modern vehicles, the concept of a tune-up has shifted to periodic maintenance tasks like replacing air filters, changing spark plugs, and checking for software updates to the engine control module. These tasks are required far less frequently than traditional tune-ups and are usually outlined in the vehicle's maintenance schedule. Number 10. Starting a car in cold weather requires warming it up for several minutes. Verdict: false. The belief that you need to warm up your car for several minutes in cold weather before driving is a relic of older vehicle designs. In the past, carbureted engines relied on a lengthy warm-up period to prevent stalling and ensure smooth operation. Modern vehicles are designed to adjust fuel and air mixtures automatically based on the engine's temperature, making extended idling unnecessary. In fact, idling your car for too long wastes fuel and increases emissions without providing significant benefits. Most modern engines are ready to drive within 30 seconds to a minute of starting, even in cold weather. The best way to warm up your car is to begin driving gently after starting it. This allows the engine, transmission, and other components, such as the tires and suspension, to reach optimal operating temperatures more quickly than idling alone. Aggressive driving should be avoided until the engine is fully warmed up, typically after a few minutes of driving. While warming up is unnecessary for the engine, it can still be useful for driver comfort, such as defrosting windows or heating the cabin. In these cases, a minute or two of idling might be justified, but anything longer is inefficient and environmentally harmful. That's all for today. If you found this video helpful, then do not forget to like, subscribe, and share the video with your car fellows.